All right, R7, radical expressions. So we're going to have different, to start with, like radicals and different values, and we're going to basically be reducing them down as much as possible. So to start with number 14, these say to write each root using exponents and evaluate. Okay, so basically, well, we're not exactly doing that. We're pretty much just reducing it down. So the fourth root of 256. So we're going to break this down as small as possible and take out as much as we can. Okay, if it ends up being a perfect root, we'll obviously have no radical left, but they won't all be that nice. So the easiest way to do this is to break it down with a factor tree. So what factors can we start to break it down with?
64 something. Right? 4, 64 and 4. Something like that.
Yes, I think so. Make sure. Yep. All right, and then what else?
8 and 8, 2 and 2.
And then the 8s can be broken down into... So when we're going to take something out, okay, we get down to whatever's left. We have to take them out in groups of, in this case, it's 4. So in groups of whatever the radical is. So I need to take out 4 2s. So there's 4. And then there's 4. So when we do that, it comes out one time for each of those. So this would give me 2 times 2, which is 4. Look familiar? All right. 16. The third root of minus 343. So if you've done a whole lot with square roots, you would know that you can't have a negative under the radical. However, with odd roots, we can. So the negative is okay under there. Does anybody know what the cube root of 343 is? Because it's a perfect one.
17.
So 17 times 17 times 17 is 343.
What number is this stuff? Is it a single?
Is it a single number? We can still break it down the same way, but it won't. Unless you know what it's breaking down, you like already. Anybody just want to guess? What? It's too high.
7.
7. Yep. So this is just going to be negative 7. Okay, if you had broken it down, okay, it was negative, so we have to make sure we get that negative sign on there. But we could have done 7 and 49, and then 7 and 7. That's why I said that one's not as nice to be able to break down, because unless you just already know it, it's not like...
So we break that down still if we know it's negative 7?
No, you wouldn't have to.
You don't have
No, if you already know like directly what it is, that's fine. You can just write it down. The only problem is if you don't write any work down and it's wrong, I have no idea why you picked that number. So it is good to go ahead and break it down. You don't necessarily have to break it down like, 343. There's only so much you can do. But the more work you show me, the more partial credit I can give you if you were to get it wrong. So it just depends on how confident you are in your answer. So 18. The fourth root of negative 256. So what do we notice about this one?
It's negative, and it's even.
Okay, so that means what's happening? The poster. Is he real? No, it's going to be a not real answer. Okay, if you were to do it, we would just have to take out an I, and so it would be minus 4I. Or sorry, not minus, just positive 4I.
Oh, we can't do a lot with eyes this year.
I mean, like your typical, like what you would do with.
I hate it. It's
Not really anything more than what you would have done in Algebra 2.
I just don't like it.
So that's not a real answer, but if you were to actually do it, it would be 4I. So, let's see. If the expression is an exponential form, write it in radical form. If it's in radical form, write it in exponential form. Assume all variables represent positive real numbers. So, 26. We've got in parentheses 5r plus 3t raised to the 4/7. So basically, we just need to rewrite this as a radical because it gave it to us in exponential form. So when we do this, okay, this was kind of going back to the last section a little bit. Whatever the denominator is our root, okay, and the numerator is the power. So this will just be the 7th root of 5r plus 3t raised to the 4th. So these ones we're just rewriting them is all.
Oh, so you don't have to like solve anything?
No, that one you just have to rewrite it. And the next one will still be just rewriting it as well. So 30 is negative m, and then the square root of 2y to the 5th. And so it just wants us to rewrite. So we have this in radical form. It wants it written in exponential form. So there's nothing happening to the negative m, so we just copy that over. So negative m. And then we need to put the stuff under the radical in parentheses because if we're going to rewrite a radical as a power, what is the power going to be? Has to be the denominator. How do we rewrite radicals the other day? Or exponents as radicals. Vice versa. No. I'll give it to you. It's not a whole number.
That's the whole number.
Oh, the fraction? Oh.
So what would it be? So the 5 is only on the y, so it's not going to be 5 over 2. But it is, you are right, it is over 2. So it's just 1/2 in this situation. The other ones that we were doing when it was like the whole thing being raised to a power, it was like the numerator was like the 5 over 2. But yeah. Let's see. All right, the next ones are to simplify. So 36, the 6th root of x to the 6th. Any ideas how to rewrite this one? What did you say? Just x, yep, because it would be x to the 6 over 6, or just x, because that would reduce. So, yeah, you don't have to show the 6 over 6 stuff, just for reference for you. Let's see, 38. The 4th root of 81 p to the 12 q to the 4. So I want to, kind of like we did with the ones that would, there was like 256 or 343 or whatever, we wanted to factor stuff down. We kind of want to do the same thing with this. I need to take things out in groups of 4, okay, because it's a 4th root. So is there anything that you know that raised to the 4th power gives you 81? 3. So we would rewrite, I'm going to rewrite this first, and then, so this is going to be 3 to the 4th power, okay, p to the 12, obviously that will allow us to reduce down, and then q to the 4th, we can reduce that down as well. So when I take stuff out, the easiest ones to see are the 3 and the q, because there are 4 of them, so that means that they're coming out one time. So I know I'm going to have that. How many p's are coming out?
No, yeah,
3. Okay, so sets of 4. So there are 3 sets of 4. So 3p cubed q. What about one like this? The 4th root of, in parentheses, 5 plus 2m raised to the 4th. Thoughts on this one?
Wouldn't that just be 5 plus 2m?
Yep. So it's the 4th root of something raised to the 4th power, so 5 plus 2m. Any questions on any of that so far? All right. So the next one, so far everything pretty much has been able to like come out. We haven't had anything left inside. But now we're going to have some where some things are left inside, potentially. So 42, the 3rd root of 250. So I'm basically going to be breaking these down as much as possible, and anything I can take out in groups of 3, I will take out. So 250 breaks down into what?
55.
Okay.
52.
Okay. So then I have a set of 5s that I can take out, and then I have 1, 2 left over. So I will have 5 and then the cube root of 2 left over. So we take out as much as we can, and then whatever's left we keep with our radical inside. Let's see, 46 is the square root of 7 times the square root of 5xt. Any ideas about this one? Is there anything I can take out, first of all? Always check that first. No. Okay. So then, do you remember what happens if I multiply two radicals that are like the same radical? It's not like one's the cube root, one's the fourth root. These are this. Down it goes. Keeps happening. Do you remember what the rule is for that? All right, so if we have two radicals that both have the same root, okay, so these are both square roots, we can multiply them together, the stuff that's inside of them. So this would give us the square root of 35xt. Now, once you multiply them together, you need to make sure, check, is there anything that I can take out now?
Yes.
What can I take out?
Oh, never mind.
Okay, so it's just 5 and 7, so that's not going to come, like nothing can come out of that. But in a lot of cases, once you multiply them, there are things that can come out. It's easier if you can take stuff out first. That's why we always check that first to take it out, but it doesn't always work that way. So that one would be done like that. 50. Negative square root of 16 over 49. Anybody remember what the rule is about this? If I have a fraction under the radical, what can I do? Separate it, so I can do, I'll leave the negative out front, square root of 16 over the square root of 49. Square root of 16 is? 4. And I'm going to go ahead and write the negative. The negative can go on top, bottom, out front, it doesn't matter. So 4, and then square root of 49? 7. Let's see. 54. 6th root of r over s raised to the 6th. So again, I can separate this like we did on the last one. So I'm going to have the 6th root of r over the 6th root of s to the 6th, which is going to give me what? Can I do anything to the top? No. So the top's going to say, what about the bottom?
It's just S.
Yep. Will just be S because there are 6 S's in there, so I can take one of them out. And so we're just left with 6th root of r over s. Let's see. 58. Cube root of 25 times negative 3 raised to the 4th times 5 cubed. Any ideas on what I can take out here? So this, you're saying, is going to take out a 5? Yep. Can I take anything else out?
No.
Anything that I have more than 3 of, I can take out.
Oh. Well, then 25, you can take that one. Wait. But that's
There's
it,
only
though.
2 of those.
Oh.
5 and 5 is 25.
Oh, okay.
So 25 is going to stay in.
Then... Wait. Oh, negative 3 to the 4th. That would be 27, right? Or something. No, it'd be...
Okay, so I'm taking out a negative 3. Okay, taking out a negative 3 cubed. Okay, so this is kind of getting rewritten as negative 3 cubed times negative 3. Okay, basically what's happening.
Yes.
So I'm taking out this one. So negative 3. So then under the radical, I'm left with 25 times negative 3. And to write this so it looks nicer, negative 15 cube root of negative 75.
Yeah, I'm getting this one wrong on the quiz.
Huh?
I'm getting this one wrong on the quiz. No way I'm gonna do that.
So like it probably feels like we're doing like an excessive amount of examples, but it's because there tends to be a lot of mistakes made with stuff like this. So
That one got me.
let's see, 66, the square root of g cubed h to the 5th over r cubed. So just like we did with the other ones with the radicals, we can still split this. So this is going to be the square root of g cubed h to the 5th over the square root of r cubed. So I can take things out in groups of 2. So what can I take out on top? You scared to answer now?
Yeah.
Anyone?
Josh.
Is it G and then H to the 3rd?
Not 3.
2.
2. And then what does that leave you with inside?
G.
Huh? I took out a set of g's, so what would I be left with?
Wouldn't that be G squared? G is like whatever, 2G, whatever the 2.
Well, I technically took out 2 g's already
Wait, how?
because I took the square root.
Oh, so you have.
So this is like, if you need to see it as a factor tree, this is like g times g times g, and then I took out a pair of them.
So you just have G left.
So there's just a g left inside. And then with h, you have h times h times h times h times h. You took out
You have 3G.
sets of 2s.
Oh, you have 1G. I mean 1H.
So I have 1 h left over. And then on the bottom, what can I take out of that one? An r? Is that what you said? And that leaves me with what? An r. Am I done?
No.
What's wrong with it?
I think it was gonna be no. I would say probably.
Can I have a radical in the denominator?
No.
Nope. Any ideas how to get rid of it? Rationalize it, yep. And what do I multiply by to do that? Yep. Multiply top and bottom by the square root of r. So on top, all that's happening is that square root of r is getting multiplied by what's inside this radical. So I will be left with gh squared and then the square root of ghr. On the bottom, square root of r times the square root of r is the square root of r squared. Okay, so you can multiply those together, which is just going to be r. So r times r is r squared. Do we follow? Okay. All right, one more, and then we'll stop for today because this has been a lot. The fourth root of the square root of 25.
Oh, okay. That would just be 5. It'd be 4. So.
Okay, so yeah, so start in the innermost part.
So it'd be 5.
Okay, so the square root of 25 is 5. So the fourth root of 5. Can I do anything else?
No.
No, so we're done. And on an easy one. All right, so there is a little bit more in this section with like adding, subtracting, multiplying, and dividing radicals. But what I'm going to do is I'm going to wait on that, and that part will not be on your quiz on Wednesday. So up
Wednesday?
through.
Your quiz on Wednesday? You told me Tuesday.
I thought it was Tuesday.
I was like, do we have it, like, what's our homework? And he just said nothing.
I mean, it can be tomorrow if you'd prefer, but
No, I just heard
He
Tuesday.
has one also.
I may have originally said Tuesday and then realized the section was super long, so we were going to have to move it. So your problem so far that will be up through what's on the quiz on Wednesday. 11, 17, 21, 37, 45, 53, 59, 65, and 73. And then after the quiz on Wednesday, I will go over the last little bit of this section. And then Thursday will be a review for a test on Friday.